Good morning, everyone. Tarun, good morning. So, today we are going to start present. Okay. So, starting the class, please give your attendance as fast as possible. Jotam, good morning. How was the test, Jotam? Chalo, without wasting time, we are going to start the class, please. Now, look into. So, first, we are going to understand in the prism that just like reflecting surfaces are there. Good morning, Kritika. Now, listen, better. Listen very carefully about reflecting surface. If somebody will be talking about it is okay, but score will tell. Today's score will take. Dhanu Shea, good morning, beta. Good morning, Dhanu. Now listen. First, listen very carefully about the class. Today we are going to do prism. Now, like other Ashwita, good morning. Like other reflecting surface, prism is also a reflecting surface. Plus, it will allow refraction also. The light will enter into it. That means what? I'm just reading out who and all are there. So please kindly inform your friends to join as fast as possible. Class started already. Now listen, Beta. So when we talk about prism, at that time we are understanding that okay, lens is there, prism is there, and all of them have one thing for common. And what is the thing that is common for all of them is they allow light to enter inside it. Okay. Now, prism is also having reflecting surface and refracting surface. So, what is the meaning of the beta? The simple meaning is the light once falling into the surface, some amount of light will be reflected also, and some amount of light will enter inside the medium also. Understood or not? That means from air inside glass. Got it? From air inside glass, the light will enter. Understood? Children, good morning. So the light will enter better. So from air inside glass, the light will enter. I hope Tarun, Jotam, Dhanushya, Kavya, Vishwa. Vishwa, which Vishwa? Vishwa part 1, Vishwa part 2. New joining Vishwa or our Vishwa? Both are our Vishwa only, but which one? So now, beta, what we are going to learn here is, prism is a homogeneous, transparent, refracting medium. Homogeneous, transparent, refracting medium bounded by at least two non-parallel surfaces inclined to one another by some angle. Okay, inclined to one another by some angle. So here, first I am going to explain this one. What and all contents are there? First, I am going to explain this one. So, it is a homogeneous, transparent, refracting medium. So, that means why it is considered as medium, beta? Because the light will enter inside it. Because the light will enter inside it. So, only it is called as homogeneous, transparent medium. And here, beta, these two surface is exactly what? Parallel, but they are not parallel. They are not parallel, and they both surface will be inclined on each other. The both surface will be inclined on each other. Understood? So this part we have understood. So non-parallel surface inclined at some angle. Now, did you see this angle making between them? So if we are checking this one, this is the angle actually subtended between them. So this is the angle subtended between them. Understood? So here non-parallel, but here see the angle subtended between the two refracting surface. The angle subtended between the two refracting surface. Okay. Now, one question is there. It is made up of glass and having three rectangular faces. How many rectangular faces does a prism have? सी रोहित इंग्लिश में बता रही हूँ बेटा बिकॉज सारे स्टूडेंट्स तमिलनाडु से हैं और उनको हिंदी समझ में नहीं आ रहा हिंदी समझ में नहीं आता बेटा इसीलिए इंग्लिश में समझा रही हूँ और सीबीएसई में होना तो थोड़ा सा इंग्लिश में जानना जरूरी होगा इसमें क्या बोल रही हूँ मैं कि refracting surface and reflecting surface, usually two different type of surface we are talking about. Okay, so whenever we are talking about refracting surface, the light will enter from one medium to another medium, beta, from air to glass. So here prism exactly is a glass, so we are taking allowing the light to enter inside it. So once the light is entering from one medium to another medium, it will exactly suffer bending. Why? Because of change in speed. Because of change in speed, it will suffer bending. Okay. So now when we talk about change in speed and it is exactly suffering bending, then we are exactly understanding that this change in speed is because of one very important factor, and that is optical density. Okay, so optical density of air will be different, and optical density of prism or glass will be different. Because of that only the speed changes when we are exactly allowing the light to enter from air to the medium. So prism is also considered as a medium, because the medium only from one medium, if we are going to take it as air, another medium we are going to take it as glass. So that time the change in medium will change the refractive index of the material, and so bending will occur. I hope Rohit you might have understood बेटा. अभी मैंने धीरे से बिल्कुल हिंदी में भी और इंग्लिश में भी समझा दिया. हिंदी में मतलब कम बोला, इंग्लिश में आई टोल्ड यू. So beta, it is having how many reflecting surfaces? If we will talk about means triangular, you see triangular faces. कितने triangular faces हैं? Two triangular faces, because here we are seeing one face and back side we will see one face. Okay, so two triangular faces will be having how many rectangular faces it will have? Beta, three rectangular faces. But one thing it is written, that is homogeneous transparent. So here the shape is exactly homogeneous. The surface is homogeneous. It is not a rough surface. Okay. So prism is a homogeneous surface. So whichever surface is undergoing refraction means whichever surface allows light to enter inside it is homogeneous surface. I hope you might have understood, children. Come on, say understood or not this one. Rohit understood, beta. So did you understood this part? That prism is exactly having homogeneous refracting surface, and it is bounded at least two non-parallel. Okay. Good morning, Anu. Good morning, beta. Inform in your respective groups to join as fast as possible. See, 8 minutes over. Now only students are. Now only Tarun is telling. Tanushia, what is the report right now? Ashwita, till here understood, beta? So you need to understand another thing. A commonly used prism is shown in this figure. We have shown the prism. The two non-parallel plane surface what we call participating in the refraction of light are called as refracting surfaces. Understood, Jotham? So these two exactly, because beta one will be in the plane now, one will be in the floor. So how many reflecting surfaces will be there? Two reflecting surfaces will be there. I hope till here it is clear, children. So two reflecting surfaces will be there. Is it clear? So this is exactly the part for the prism. So now the angle between the non-two, this what is the angle of the prism? First, we are going to understand what is the angle of the prism. So if somebody will be asking you about angle of the prism, then you will be saying these two non-parallel surfaces there, the angle subtended by this, and it is exactly considered as what beta? A. And this is exactly considered as what beta? Angle of the prism. What it is considered as? Angle of the prism. What it is considered as? Angle of the prism. This A is what? Angle of the prism. I hope till here it is denoted by A. So till here is it okay? Did you understood this part? Huh? So this is the content related to prism. Now we are going to understand the next important part about prism. That is the practical learning we are going to do about prism. Okay, practical learning about prism. The first important thing is find angle of deviation. So this is exactly about angle of deviation. Understood? So beta, first one thing I taught whenever I am teaching, I explained one thing, that it is having a refracting surface. So if somebody will be asking you it is having a refractive surface, means it will allow light to enter inside it. Understood? So the light will enter from one medium to another medium. The light will enter from one medium to another medium. Children, if you people are not listening, attendance is taken. Today I am going to send a report to every parents. Wait. So here, exactly what is the situation is, that is place a glass prism on the sheet of white paper. So we are going to take a prism on the sheet of white paper. Understood? So when we are placing a prism on the sheet of white paper, then we are going to try to understand this one. Okay. Now nothing we are exactly knowing. First time we are trying to understand. But one thing we know, that it is a medium. One thing we know, that prism is also a medium. Light will enter inside it. Light will enter inside it. Another thing we are knowing about glass or any other medium, that if the light is entering, what is happening is, if the light is entering, the light will suffer refraction, means it will go bending. Understood? Bending either away from the normal or towards the normal. This is the second point. And this bending or change in speed or change in refractive index is due to what factor? What is responsible for exactly bending? What is responsible for refraction? The correct answer is optical density. Change in optical density of the material is responsible for doing one very important work, and that is changing the speed and changing the what? Will the frequency be changing? One question we have already discussed, Jotam. Everyone, can you tell me, will the frequency be changing? Speed is 100% changed. Understood, Nandita? Speed change will be there, and it will exactly change the bending. It will not use its usual path. It will either bend towards the normal, or it will go away from the normal beta. So these are the things that the light is suffering. I hope you might have understood this one, children. Okay. Now we will go for the next part, children. Now look at that. So now first we are with the angle between the incident ray and emergent ray is called angle of deviation. But where is the angle of deviation? First we are going to understand where is the angle of deviation. So now first we are going to see this. So which one is the usual path? First we will check. So exactly we will see here. This is exactly the path of the light. The light is exactly entering like this. Okay, by making some angle with the normal. Maya, good evening. Good evening, because morning means 6 o'clock. 13 minutes late. 13 minutes late, Maya. Respond quickly to me. Okay, beta. Vishwa. This is very bad. Either you people join online or join offline, but you must be present here. Today, one call will reach to every parent. Wait, this is only waiting now. This is only waiting. Now look here. So now look here. So when the light will be exactly entering, when the light is entering by making some angle with the normal. So let's draw the normal first. Where is the normal? Jivita, is this the normal? Yes, this is the normal. Normal is making what angle with the surface? 90 degree with the surface. Angle is exactly what? Normal is making what degree with the surface? 90 degree with the surface. I hope material reached you. Your first material reached you. And this is again another normal, because it is having how many surface? Two reflecting surface. Now surface is three. See here that are talking about this surface is there, but at a time how many reflecting surface we are taking for the prism? Two. This rectangular region will be the reflecting surface we are going to take. Good morning, Vishwa. Good morning, Vita. Dhanushya, come on, see me. Good morning, quickly. Dhanushya, you need to say me good morning. The moment I'm taking your name, you should respond quickly. Krish, good morning, beta. I think Vishwa, correct. Vishwa, good morning. Now look here, beta. The movement, this is exactly the normal. This is the actual ray. Huh? Now the moment the ray is trying to enter inside a prism, the moment the ray is trying to enter inside a prism, it will what? Experience deviation. Understood? Bending. Understood? The light ray will experience what? Bending or deviation. Is it towards the normal or away from the normal? It's towards the normal. So here, if this is exactly the actual one, we will draw this one. This is exactly the actual right way. So this is the actual right way. It was supposed to go like this, na? It was supposed to go like this, but is it going like that? No, it got deviated. It got what, beta? It got deviated. You see, this is the deviation. Is this the deviation? No. This is the expected path of the light ray. Understood? So this, if we will talk about BF, was the light ray and it was supposed to go to F this side. Understood? But is it going to this direction? No. It is not at all following that direction. It went towards the normal. It went towards the normal. It bend towards the normal. So if it is bending towards the normal, means now it will make some angle with the normal. Understood? So here this angle is considered as R1. This angle is considered as what, beta? R1. So now we are going to go with the next part. So this angle is considered as R1. And now the other way, the other side of the prism, again the light ray has to come out. Again the light ray has to come out. So what we are going to do here, see another exactly normal is there. Now the light ray was supposed to, see, this is exactly the path. So it was supposed to go, see, once the light ray is coming like this, the light ray is supposed to go like this direction, huh? But is it going like this? No, it is exactly changing. It will now, this time the normal is this one. It is going away from the normal. Away from the normal. So this is incident angle and this is emergent angle. Understood? That is Sarna, good morning. This is incident angle and this is emergent angle. Now beta, incident angle, emergent angle, again this emergent angle is going back. This is the expected path of the emergent ray. Okay. So this light ray, if I am going to allow it to go inside backward direction, then the angle between the incident ray and emergent ray is called as angle of deviation. The angle between the incident ray and the emergent ray is considered as the angle of deviation. So angle of deviation is angle between incident ray and emergent ray. What is the angle of the prism? A is the angle of the prism. D is the angle of deviation. So one more time we will try to draw and learn it. So let's check this one of Jotam. Are you there? All the students, are you there? So all the students, are you there? Come on, say quickly yes. Quickly you have to say yes. Jotam is there. Without fail, without wasting time, Krish is there, Vishwa is there, Divya is there, Maya is there, Ashwita is there, Savana is there, Vishwa is there, Jotam is there, Tarun is there. See, Paranay, good morning. Paranay is there. Now Dhanushya, she joined, and after that, where is Dhanushya? 3 times I called her name. Still now, she is not responding. You can't join and just go for sleep, because at the time when you are joining, Kritika is there. At the time when you are joining, after that, if you are going to sleep, means most of the time I am calling your name. Divya, now look here, beta. Kritika is there. Anu, Divya. Now look here, beta. This is the reflecting surface. This is the normal, and this is the normal. The light ray was supposed to enter like this. Understood? So it was supposed to go like this. But it did not went like that. What it did, it went towards the normal. It met here. Wait. came here. Now again normal is there. Understood? So it was supposed to go like this, but it went away from the normal. Understood? It went away from the normal. So once it went away from the normal, the ray is exactly the trace dot expected path of the ray was this. Understood? So this is incident angle and this is emergent one. So the angle between the incident ray, this is incident ray and this is emergent ray. Emergent ray going backside. Emergent ray is going which side? Backside. And this is exactly considered as what beta? Unnati, good morning beta. So this is exactly considered as what? Angle of emergence. Correct? No. That is called as angle of deviation. This is angle of emergence. Incident, emergence, deviation. Understood? And this side is refractive angle. Angle of refraction. Inside how many angle of refraction? Angle of refraction 1, angle of refraction 2. This is incident, deviation, emergence. That's it. Okay? So you need to practice it. Okay? You need to practice this again and again so that you will get a perfect idea. Okay? So this is exactly. So one more time, are we going to draw? Because the entire story of the prism is in this only below. So what is exactly there? One more time, are we going to understand? So this is exactly the prism, and in this prism, now please pay attention. This is normal. The light ray entered like this. It was expected to go like this. But is it going like that? No. What it happened? It went towards the normal. After that again, it is going away from the normal. So this is exactly going here. It is called as emergent angle. Okay. Now this is just the beginning part we are studying. But are we have to? Do we have to satisfy with this beta? No. We should not be satisfied by the statement. Okay. The first important thing is we should not be satisfied by what we are learning. We should learn bit extra. Okay. Now I am going to explain some things. Let's see this one out. Now, this is exactly the experiment related to the pin. So, one pin experiment is there, and that pin experiment is exactly telling that, okay, I am going to take a prism, okay. After that, the rectangular region of the prism will be there now. So, now what we are going to do is two rectangular faces are there, or three rectangular faces are there in a prism. Two or three? Two or three? How many rectangular faces a prism is having, beta? Ashwita is telling three. Check. Here, here, rectangle, down. Ashwita has given the answer first. Very good. Well done, beta. Yashi, good morning, beta. So now look here. Good morning, Yashi. So now look here. So this surface and this surface. What about the reflecting surface in the down? That is also there now. How can we ignore that one? Correct now? That is not undergoing for refraction, but exactly two surfaces at a time we are using, but it is also there now. Understood? It is also there. So we have to use that surface also. Understood? So how many refracting surface? How many rectangular regions are there in a prism? Three are there. Okay, two we are using for refraction. Is it understandable? Now, beta, we will go for the pin experiment I told you now. So you have to nicely place this one, and you have to exactly look through. So you have to put pin in two directions. Okay, so here we put pin. Got it? So here one pin, two exactly surface you are going to put pin, and then one ray you have to draw, and then you have to put pin in that. By making some angle, you have to put pin in that. After that, come this direction and try to look the pin from the other side. Okay? So wherever you are feeling the pin heads are joined, means only one pin you are able to see. Two pins you have to make one line. In that you have to fit two pins after some interval. After some interval, you are going to fit that. Okay. After fitting that beta, you have to come in this side, and from this side you have to angle in such a way so that both the pin head should be looking one. Means you should be able to see only one pin. Exactly on that ray what you have drawn, it is having how many pins? Two pins. But how many heads are visible at a time? One. That means the exactly path is same. and that you have to eye on the prism and you have to fit that two pins. Okay, two pins after some distance, and then you take out the prism, and then you will be finding this type of deviation. Understood? So this is a test through which we can be able to check the deviation. I hope it is clear, beta. Is it clear? So now this is the experiment what I talked about. Now we are going to talk about dispersion of white light through a glass prism. So dispersion of white light through a glass prism we are going to understand. What is the meaning of dispersion? Okay, what is the meaning of dispersion? Dispersion means what? Huh? Very good. Scattering of white light. Okay. Another question from Unnati or Kritika. Okay, fine. I'm going to ask from Kritika. Anu, are you there? Anu, Kritika, Unnati. My question from you is, beta, why there is a splitting? Why there is a splitting of white light through a glass prism? Why there is a splitting of white light through a glass prism. So when the light is exactly entering through the glass prism, why there is a splitting? I want this answer. Tarun, splitting is there, we all know that. But why? And what is actually splitting here? What is actually splitting? Someone will say something which you will trust. No, you should not be trusting. You should be first understanding, and then you should use your brain, and then you say. Yeah, splitting will be there, but why, how, in which way splitting will be there? Jotam, do you have any answer? Anyone having any answer? Those children who have joined just now, just be very careful and start answering the question. You should, yes. Come on, say me. See, splitting is done because of change in speed. Okay, change in speed. So now look here. When white light passes into splitting of white light into seven colors is called dispersion. That is the exactly the splitting of white light into, so the white light which is entering inside the prism will split into how many colors? Seven colors. So when white light passes through a prism, we get a band of seven colors. Okay, and exactly we are going to see that. Now, what is the starting color for it? So we will be talking about violet, indigo, blue, green, yellow, orange, and red color, and they can be remembered as what? Beta, Vibgeo. Correct now? The seven colors of specific wavelength. The seven colors of specific wavelength will be exactly considered here. The seven colors of specific wavelength. The seven colors of specific wavelengths we are going to study here. Okay. Now the first important thing, I think most of you have not listened me, or if you might have listened me, I told that splitting of white light in how many colors? Difference in the degree of refraction experienced by several colors inside the glass prism. Absolutely correct, beta. Difference in refraction. So, beta, this refraction, whatever is occurring, how it is going to occur, that also we need to check. Yes, seven colors it is going to split. That's correct only, Namita. Seven colors it is going to split. Now we need to understand some of the most important things here. Okay, how, why, when, in which way it is doing. Optical density is change in what you call change of optical density from one medium to another medium is there. Second important point is change in optical density from one medium to another medium is there. But another important thing also is there is change in speed. Understood? So wavelength is also changing. When the speed is changing, wavelength is changing. Because we know the formula, speed is equal to wavelength into frequency. Understood? Speed is equal to wavelength into frequency, children. Speed is equal to what formula, beta? Wavelength into frequency. Vishwa, can you tell me, beta, because auntie got stuck in a very important thing. The observation we can conclude that white light is a mixture of 7 colors. The phenomenon of splitting of white light into 7 colors is known as dispersion. So now let's see how dispersion is exactly occurring. So the light, Sarvana, what happened? Now the moment it is exactly going, the splitting will start like this. Okay. Then after that it will bend like this and come out. Correct? So it is exactly done like this. Correct or wrong, children? Come on, say fast. Is it done? The answer is yes. Okay? The answer is yes or no? Come on, I'm not fitting the answer. I want my children to say the answer. Come on, beta. Vishwa, say the answer, beta. The splitting of colored, yes. Jotam is giving the answer, yes. Yes. Jotam has given the answer. Ashwita has given the answer. Attentive children are given. Oh, good morning, Sophia. Your sleep got broken. Today, what exam today we are having? Tamil. Today I speak in Tamil. Wait. Kritika, yes, beta. So now look here. So now we are going to talk about the splitting of white light into 7 colors. It will be investigated by whom? Who is the person who investigated the splitting of white light into 7 colors? It was Sir Isaac Newton. He has exactly came to explain this factor for the first time. Understood? So that means it was investigated by whom? Sir Isaac Newton is the person who has investigated this one. Understood? That is the splitting of white light into 7 colors when it passes through a prism was investigated by whom? Sir Isaac Newton. Understood? Now composition of white light. Now we are going to see the wavelength also and its composition, beta. So when white light is a mixture of how many colors, beta? 7 colors. Okay. So violet, indigo, blue, green, yellow, orange and red. Every color has its own characteristics, wavelength. Okay. So now let's read about the wavelength. So different colors with their wavelengths are given below. So red color is having maximum wavelength. What is the maximum wavelength of red color? 7900 angstrom. Understood? Angstrom. So 1 angstrom is 10 to the power minus 10 meter. Like that it is. Okay. So here you need to understand that here you need to understand one very important thing, children, that the wavelength of 7 colors are not same. And when you will be checking the wavelength, you please notice one thing. The red color suffering minimum deviation. The red color is suffering what deviation? Maximum deviation is experienced by which color? Come on, say maximum deviation. Satya, wait. What is the time? 3:34 minutes after class you are joining. Monkey. So, beta, very good, Ashweta. Ashweta. So, which color has experienced maximum deviation? She has answered the color as violet, and violet is the correct answer. Bingo, Ashweta. Super, beta. So now look here, beta. Understand one thing. When we are learning, one very important thing that okay, once the light is entering, one white light is entering from one medium to another medium inside the prism, exactly it is splitting into 7 colors. Then after that we came to know that the splitting is because of change in optical medium. After we have learned that okay, change in optical medium is there. Change in optical medium is there because of that change in speed is there. Understood? And speed change will split the color into how many colors? 7 prime colors. Understood? And in that one, the one which is having minimum bending will have maximum wavelength. So one which is experienced minimum bending will be having maximum wavelength. Why the formula is here? The formula is here. Why the formula is here? Hey, come on, Sophia. Good morning, Sophia. Can we answer this question? Vishwa, chalo, you answer my question, beta. So the formula, Vishwa, look here, beta. The formula is B is equal to lambda into frequency. Understood? So where B is what, beta? Velocity of light. And this is wavelength. This is what, beta? Velocity of light. What is B, beta? Velocity of light. Latika, good morning. So velocity of light, this is wavelength. What is this, beta? Wavelength. And this is what, beta? Frequency. Understood, beta? So here velocity of light, wavelength and frequency. So इंस्टा आईडी, अरे चेक किया तुमने हमारा जो सारा जितना भी वट एवर चैनल का जो अपडेट्स है ना उसमें इंस्टा आईडी फेसबुक का सब कुछ लिखा हुआ है, एक बार चेक करो। आप ग्रुप बनाइए, हम आपको आके पढ़ाएंगे, कोई प्रॉब्लम नहीं। आई एम रेडी टू टीच बेटा, चेक कीजिए। Now understood beta, velocity is equal to wavelength into frequency beta. Velocity is equal to wavelength into frequency. Velocity is equal to wavelength into frequency. Done beta. So now here one thing you see, if the velocity means the speed of the light ray is maximum, that means its wavelength will be maximum. Correct na? Keeping frequency constant, because at a time we can compare any two. Understood? कंपनी वालों को थोड़ी ऐड करेंगे, मुझे समझ नहीं आया राजेंद्र, मुझे समझ नहीं आया। Now look here beta, understand this one. So here wavelength and frequency and velocity all are interconnected, but keeping one constant, we can compare any two. So that means what we have learned here is कि when the light is exactly having maximum speed, its wavelength will be more and frequency will be less. Did you understood here, beta? Did you understood this here? टीचर्स का ग्रुप, ठीक है। I'll say. Now look here beta. So what is exactly talking about? What we are talking about? मेरे नाम पे देखो, इंस्टा मिल जाएगा। Now look here. So red color, maximum wavelength. Speed is more or less. Children, come on, get back to work. Now maximum, red color will have what? Maximum. Come on children, start responding. Wavelength. Maximum wavelength is red color. Speed will be maximum. Children, come on, get back to work. Speed. I'm not getting the answers. Come on, go for it please. Come on children, get back to work. I'm not getting answers children. See, speed maximum, wavelength maximum, frequency minimum. Understood? So bending is minimum, frequency minimum, bending is minimum. Understood? Bending maximum, frequency maximum. Understood or not? Wavelength minimum. So here we need to understand one thing for red color. Let's see. So here what deviation is less. Understood? So deviation is less means bending is less. Got it? Bending is less means frequency is less. Understood? Now wavelength and speed, mode. Understood? Note down this one, children. This is the entire content, beta. This is the entire content. Come on, get back to work, please, children. So here, deviation is less. Understood? Why deviation is less, beta? If you will be seeing, the moment the split of color will be there. So specifically, when red light is color, it is splitting very less. Understood? So here you see, deviation is less means bending is less. Deviation is less means bending is less. Now here another colors will exactly bend more. So last will be coming as B, violet. So violet bending is maximum. Bending is maximum. Now deviation is maximum. Now frequency is maximum. Which one is minimum? Wavelength is minimum. Speed will be minimum. Speed, wavelength and speed up more, red color more, but here it is less. Understood? So note down here deviation is maximum. So bending is maximum. Why? Because bending is maximum. Frequency is maximum. Now frequency is maximum. What is minimum is wavelength and speed is minimum. Wavelength and speed is minimum, and rest other color comes between them. Rest other 5 colors are coming between them. Understood? So rest other 5 colors are coming between them. Is it crystal clear, children? Come on, give me yes. Come on, give me yes. Is it crystal clear? Deviation is less. Deviation is less for which color? Red color. Wavelength is maximum. For which color? Red color. Deviation is maximum. For which color? Violet color. Wavelength is minimum. For which color? Violet color. Frequency is maximum for which color? Violet color. So like this we must remember, and rest other. Tarun gave me first thumbs up. Well done, beta. What about the other children? Come on. Surviro, उठ जाओ. सुबह सुबह तो तुम सोते हो. नींद की उंगली लगाओ. Red color. Okay, very good. Kritika, Tarun only have responded. Okay, Krish has responded. Come on. Maya responded. Hey, like this only I need here. Come on, come on, come on, come on, come on, come on, come on. Vishwa, virology. Jyotam, absolute. Now it is coming correct. Still Vishwa, Dhanushya, these two children have not responded. Morning take told yes. Hi, good morning. Vishwa, good morning. Wait. Sarvana, yes. This is one Vishwa, you beta, another 2 Vishwas or same Vishwa in 2 different systems. You say this one first. Is it done, beta? Now we are going to go to the next part. So see, this is exactly the white screen, and here only we have exactly captured the 7 color pinhole. The light is exactly not scattered. A ray of light when we are saying white light. Understood not? We are not talking about beam. Understood? Beam means more light rays will be exactly going. That is difficult to get. Okay, so only one ray of light is going, then only it will split into how many colors, beta? 7, 9 colors. How many colors? 7 colors. You see, one pinhole, the light ray is exactly, white light ray is exactly allowed by the pinhole. The pinhole, through the pinhole, the light is exactly falling on the prism, and there only, beta, it will split into how many colors? 7 colors. There only it will split into how many colors, beta? 7 colors. So causes of dispersion. Okay, what are the causes of dispersion? So white light consists of how many colors, beta? White light is consisting of 7 colors. Okay, now which will have its own wavelength. That means what is the conclusion? Each color is having its own wavelength. Each color is having its own wavelength. Very good. Jyotam, each color is having what, beta? Yes, it is so easy. Absolutely correct, beta. 11th and 12th, beta, I'm teaching maths. I'm a math specialist. Yes, in my channel you will get the videos of maths also, beta. So now look here. So we will be talking about the wavelength is where the speed is speed is medium, speed is also large. So that already we have covered now. What we discussed already we have covered that part. What we discussed, come on, memory is very weak. So I'm going to physics no beta. I'm math specialist. Okay, because I'm doing PhD in maths only and my MSc, BEd, everything is done in maths only. Now listen. Shall we get back to work till 10th beta because I have done BEd in yes. So I am doing that work only. Shall we go back to work? So now one thing I am going to know about you people. Children, can you tell me one thing? Just respond me quickly. Wavelength maximum. Speed dash. Fill that. Wavelength maximum. Speed. Wavelength maximum. Check करेगा फिर से. Wavelength maximum. If any ray of light is entering inside the prism is having maximum wavelength, then its speed will be what? Maximum. Very good. Deviation will be minimum. Deviation will be minimum. Bending will be minimum. Understood? Better deviation will be yes, absolutely correct, children. That's what I have discussed, and that is what now we are reading it. So what I have discussed, that I am exactly now reading it as. So what we have learned that if a light ray is entering from one medium to another medium, the one which is experiencing less deviation, less bending, will have less frequency. Deviation, bending, frequency, less. Deviation, bending, frequency, less. But what is more? Deviation, bending, frequency, less. But what is more there with us? Wavelength more, speed more. Absolutely correct. Wavelength more and speed more. I hope you might have understood. So now here we will understand one thing. If the wavelength of a color is large, the speed in a medium is also large. Thus each color of light travel at a different speed in a given medium. So speed of red color is more and speed of orange color is less. That's what we have already discussed now. Speed of wavelength and speed is maximum. Then frequency is minimum. Frequency is minimum. We keep two contents same, one thing constant and compare two at a time. Okay. So now speed of orange color is more than speed of yellow color. So with your we will start V from down. With your will start V from down. So therefore in the glass prism, red has the highest speed and violet has the least. That's what already I have written. Okay. So hence all color of white light are refracted by different amount while passing through the prism and emerge at different angles. Yes, the angle is also changed. The angle is also changed. The speed and wavelength is exactly maximum for red color and speed and wavelength is minimum for the violet color. Understood? And all the other colors, wavelength comes in between them and each wavelength will make some specific angle of emergence when they will be coming out from the prism. Understood? And it will be traced on where beta? On a screen. Where we are going to capture it? On a screen. I hope till here everything is okay. All of you have understood this part beta. Now we are going to the angle between two non-parallel reflecting surfaces, angle of the prism. Already we have learned practical learning. Now we are going. So Sir Isaac Newton has made a device, okay, which can be proved by Newton disk experiment. A circular disk of cardboard is painted with color, that is radial band order of these color, and their respective width are the same in the spectrum. So what he has done actually in this experiment, anybody can explain the experiment? Now listen beta. So one cardboard he has cut. What is the shape of the cardboard beta? circle. And after that, what he has done? 7 sectors or segment. Sectors. A cake has how many say? How many? What is the shape of the cake? Circle. Now this is sector 1, 2, 3, 4, 5, 6, 7. Understood? And each sector is having same what? Same angle at the center. So check here. So this angle, 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 all are same. Understood? So we are going to talk about this. Please check this one out. So here, this angle, 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 all internal angles are same. Understood? So that means each 7 sectors are having same angle. These 7 sectors are having how many angles with the same angle. And beta here this angle, all this is exactly having what? Same angle. And now what he is doing is rotation with a rapid speed. He allowed it to rotate. So this is exactly about to rotate. So after rotating to a very high speed, what actually he has observed? The 7 color combined to give almost white color, but not perfectly white because pigment color is instead of spectrum color. The disc will not appear perfect white, but give dull appearance of which color? White color. Understood? Because see, if we want to know, listen children, one thing more is there. So if I will be color, means you need to understand that for violet color also, see why his experiment he is exactly experiencing a dull white color, not a perfect white color. You know why? Because there is a simple reason behind it. After that, I am just going to explain this one. So, pigment of colors are impure. Thus, the disc appear grayish instead of perfect white. Understood? So, now I am going to explain you what is actual reason behind it. So, listen everyone. What he has done is he took a circular disc. In that, 7 equal sectors he has made. Understood? How many? 7 equal sectors he has made of same angles. Understood? So now at the from the center exactly how many he has made? 7. And in that he has colored different 7 different colors starting from red to violet. And then he allowed this disc to rotate fast. He allowed this disc to rotate fast. After rotating, at the time of rotating fast, what he observed is the 7 color combined and it is looking like something grayish. Okay. Now, why it is not showing white? It should show white only, now. It should show what color? White color. But why it is not showing white color? The only answer behind it is the pigment, the wavelength of the colors were not the same. Understood not? So, do you need to understand that violet color also will have several wavelengths? Need to understand this. Yellow color will also have several wavelengths. So in yellow color also different variety of yellow color is there, na? Bright yellow, dull yellow, different yellows. The yellow itself is split into many colors. Understood? Now different part means red color also will have different colors, the wavelength. So because the pigments were not that sharp, because of that only we got a dull grayish color, not a perfect white color. I hope you might have understood this part. Come on, children, did you understood this section? Hmm? Come on, say understood. So we got this one. So investigate dispersion of white light in a glass prism. Place a thick cardboard having a small hole in front of the glass prism. Allow sunlight to fall into the hole in the cardboard. Allows a beam of white light to fall into the prism. And then we will be seeing that's exactly. So fall on the glass, white light split into how many colors beta? 7 colors. This is exactly called as dispersion of white light. Already we have studied. Now we are graduating in this content. So we have understood most of the important part. So now this is exactly one thing that is totally different. Now one thing is more there. Hi Preetam. Now listen, madam. Now, when we are discussing in all this phase, one thing is again there. Now, what if I kept a prism? After that, I change the invert the prism, and then I will allow the same seven color to fall into it. Then what we are observing here is the color which was exactly split here, it will split there, and it is exactly going to radiate and come out like that. Understood or not? So why this is so? It will split again. The split part will combine together and come out as one. Understood? And it is come out as one. So this the split is exactly to merge as one color. Understood? So here, and that is white. So when it is exactly happening, a ray of white light coming from a hole in the cardboard X is made to fall on a prism A. Now another cardboard Y we are putting, and then we are tracing it in between two prisms, and A and B, and we are exactly getting the light if we are diverting it. This is in CBSE children. Please kindly listen this one very nicely. So when you will be exactly keeping it like this, yellow color is falling in down location. Okay, red color will be falling in up. Why? Already I have explained, because of less deviation, more speed, more wavelength. Red color will be coming at first, and yellow will be going down. But beta, when you will be, just see my white screen you are keeping, and when you will exactly change the location, change it invert, what will exactly going to get experience, beta? Ashwini, good morning, beta. You see, if yellow color is going down in this one and yellow color is going up. Understood? So deviation is exactly going to change. That's what one thing is there. So many times in CBSE, you will be seeing the type of questions where they are asking about this experiment. Specifically, I'm talking about this one beta. Many times they're talking about this content. They're telling that if a prism is exactly in this location, in which location, Ashwini, I'm explaining this one more time, beta. Ki if a prism is there and in that prism a light ray is entering, then because I have already taught in the previous part of the class, in the beginning of the class, that the red will be experiencing more deviation or less deviation. Deviation is less, beta. Deviation is less means it will bend less, it will speed will be more, so wavelength will be more. So red color will be traced first in the screen, and after that yellow color will be traced. So when you are keeping prism like this location, same prism, if you will invert it, what we are going to experience is the yellow color which was coming down is now going to trace in up location. Okay, that is because of change. That is because of beta change in location. I hope you might have understood this one, beta. Now we will be going for the next one. What is the conclusion of this activity? Conclusion is the glass will split seven color of white light passing through it, and the prism does not produce any color by itself. Understood? सही से समझ नहीं आ रहा है बेटा, स्टार्टिंग वाला पार्ट है ना, उसको एक बार फिर से देखो ना तो तुमको समझ में आ जाएगा। स्टार्टिंग का क्लास का जो मैंने पढ़ाया ना, उस समय वेवलेंथ के बारे में बताया बेटा। उस समय मैंने बताया कि डेविएशन कैसे होता है, ऑप्टिकल डेंसिटी की वजह से होता है, ये सारा बात मैंने पढ़ाया बेटा। और उसके बाद मैंने ये मतलब टिल हियर हम यहाँ तक पहुँचे हैं, और उसमें हमने एक चीज़ बहुत इंपॉर्टेंट पढ़ा वहाँ पे कि जब भी कोई वाइट लाइट प्रिज्म पर फॉल करता है तो उसका जो डेविएशन होता है बिकॉज ऑफ चेंज इन ऑप्टिकल डेंसिटी, तो वो जो चेंज होता है उसकी वजह से क्या होता है कि हर वाइट लाइट जो है, जो एक मीडियम से एक रे लेके जाना, ठीक है, बीम मत लेके जाना, तो वो क्या करेंगे, वो 7 में स्प्लिट कर जाएंगे। मतलब जो व्हाइट कलर है वो कितने कलर में स्प्लिट करेंगे, 7 कलर्स में स्प्लिट करेंगे ऑफ स्पेसिफिक वेवलेंथ बेटा। ओके, ये चीज बताया। दिस वन ओनली आई टॉट यू ना। नाउ achromatic combinations. So what is the meaning of achromatic combinations? Remaining part I am going to teach in the next class, because we have to talk about rainbow also and atmospheric refraction. I think that part is left. So combination, this section, the atmospheric reflection part, we still have to cover. So next class, one more class, we are going to study this one. Okay, it's time now. So one more time, come on children, let's have a rapid fire. Ready? Ready for the rapid fire? Prism and air, which one is a denser medium? Prism or air, which one is a denser medium? इससे easy question और क्या हो सकता है? Prism and air, because prism. Absolutely correct, Ashwita. Ashwita has given the answer first. You need to answer first. Only first person name I'm going to take. Come on. Next question. Wavelength maximum for which color? Wavelength maximum for which color, beta? Wavelength maximum for which color? Absolutely. This time Jotam has given answer first. Ashwita second. Okay. Wavelength maximum. Bending maximum for which color? Bending maximum for which color? Bending maximum for which color? Absolutely. This time Ashwita has given the answer first. Vishwa B only. Super. Shortest way. Bending maximum for which color? Violet color. Super. Now, which color? Orange comes before yellow or after yellow? Orange comes before yellow or after yellow? Very good, very good, very good, very good. Before yellow, absolutely. Next question, next question, next question. Angle of prism, angle of prism. Usually, angle of prism. Come on, come on, come on, come on. Angle of prism. What is angle of prism? Angle of prism. A is the angle of prism, and when we are talking about the angle of the prism is exactly the angle between the two non-parallel reflecting surface. The angle is the angle between the two non-parallel refracting surface. Absolute, absolute, absolute. After yellow, yes, Ashweta. After before, she got confused because Vibjur she is reading, red to Vibjur she is getting. Okay, super. So next class we are going to start with this beta. Bye everyone. Have a nice day. It was a very nice session. Bless you all. Bye bye. Angle between two refracting surface. Absolutely correct, beta. Bye everyone.